recording is on the.
Okay, good afternoon, everyone. Today I'm presenting my seminar on the topic linear and simultaneous equations. Firstly, I want to introduce all about the equation. An equation is a condition on a variable. Now, what is variable? Variables mean something that vary or change. Variable can take different numerical values as this value is not fixed. It is denoted by letters or alphabets like X, Y, Z, element P, etc. Why using variables, we form expressions by performing different operations like addition, subtraction, multiplication, and division on variable. In equation, there is always an equality sign. The equality sign shows that value of the expression on the left hand side is equal to the value of the expression on the right hand side. Now, what is linear equation? The word linear comes from the word linearis, which means created by lines. A linear equation is an algebraic equation in which terms are constant or a product of a constant and variable. It does not contain variable with exponent other than 1. The graph of a linear equation is always a straight line. A linear equation has no operation other than addition, subtraction, and multiplication of a variable by constant. A linear function is a function whose ordered pairs satisfy a linear equation. It can be written in the form of function of x is equals to mx plus b. There are examples of linear equation. 2x minus 4 is equals to 6x plus 2 is equals to 2x minus 9, etc. Now, linear equation in one variable, the standard form of linear equation is ax plus b is equals to 0. Here, a and b are the real numbers. This equation has only one solution. Now, what is solution? A value of variable which satisfy the equation is the solution of that equation. For example, in equation 4x plus 5 is equals to 9, we all know that only x value is equals to 1 satisfy the above equation. This is the solution of the above equations. Equation can be in the different form, having one variable on one side, having variable on both sides, and complex equations which you reduce to simpler form to find the value of the variable. Here are some properties which we use in the balancing method. If the same quantity is added to both sides of the equation, the sums are equal. If same quantity is subtracted from both sides of the equation, the difference is equal. If same quantity is multiplied or divided on the both sides of the equation, the product or the quotient will be equal. This is the properties of the balancing method. And now one another method we use to solve the linear equation in one variable, two variable is transposing method. Here is some examples of the linear variable in one side by using a balancing method. For example, in the first equation, x plus a is equals to b form. Here is the equation is x plus a, 8 is equals to 18. Here we subtract 8 from the both sides of the equations by solving balancing method and get the value of the x. Now, in this method, we can check our solution is true or not by putting the value of the x in the above equations. Similarly, as you can see that here is the left hand side is equals to right hand side is formed, then this signifies that our value is true. Now, next is transposing method, which we mostly use to solve the linear equations. In transposing method, we transpose one term to the other side of the equality, and from right hand side to left side side to right hand side. For example, in the equation 2x minus 3 is equals to x plus 2. Firstly, it is the linear equation in one variable when the variable is present on the both side of the equation. In the solution, as you see, 2x is equals to x plus 2. Here I transpose minus 3 to the other side of the right hand side of the equation. Here, this is the transposing method. By using transposing method, we find the value of the x is equals to 5. Sometimes the equations exist in the complex form, that is not simply in the linear form. In that time, we use different method, that LCM method, bracket opening method, cross multiplication method used to simplify the equation to form into the linear form. For example, in the first, you can see the fractional form of the equation is present here. By using the LCM method, we firstly reduce the equation to the simpler linear form, then solve the equation. Then at the end, we get the value of the n. By bracket opening, we solve the bracket. By bracket opening, we solve the equation and get the value of the t. In the cross multiplication method, we cross multiply the equations as 8 multiplied by the x plus 1, 3 multiplied by the 2x plus 3, then calculate the value of the x. Now, linear equation in two variable and simultaneous equation. An equation is said to be linear equation in two variable if it is written in the form of ax plus by plus c is equals to 0. Here are the two variables you can see x and y are existing. For example, 10x plus 4y is equals to 3, 5x plus 3y minus 30. These are the examples of the linear equation in two variable. A linear equation in two variable has infinitely many solutions. Two convenient solutions of an equation in two variable are the form of 0y and x is 0. These are the two convenient solutions. The graph of the linear equation in two variable is a straight line. Every point on the graph of a straight line of linear equation is a solution of the equation. Thus, it have infinitely many solutions. Next, here is the graphical presentation as well as the values which I derived for the linear equation in two variable. For in the most easy way of getting a solution is to take x is equals to 0, and by putting x is equals to 0 in that equation, you can find out the value of the y, and by getting y is equals to 0, we can obtain the value of the x. Similarly, in table you can see that I take the value of the x, then evaluate the value of the y, then draw a graph. As the graph says that there is straight line is formed, which we already discussed in the properties, that straight line is formed in the graph of a linear equation in two variables. Sometimes the linear equations in two variable is in the form of y is equals to kx. It is not in the standard form, but here it is the two variable exist in this type of equation. These type of equations solved similarly by taking the value of the x by, and when we solve the value of the y, and there is a straight line formed in which a straight line is passes through the origin. As you see in the graph, y is equals to 2x is the equation whose graph is passing through the origin. X is equals to 0 is the equation of the y-axis, and y is equals to 0 is the equation of the x-axis. The graph of x is equals to a is a straight line parallel to the y-axis, and the graph of y is equals to a is a straight line parallel to the x-axis. Now, basically, for linear equation in two variables, there are infinitely many solutions. In order to find a single solution for an equation in two variables, two equations should be known. This set of equation is a finite set of equation from which common solution is sorted out. This system of equation is called simultaneous equation. The most general form of the pair of the linear equation is a1x plus b1y plus c1 is equals to 0. a2x plus b2y plus c2 is equals to 0. Here a1, b1, c1 coefficients are really real numbers. This equation is solved by two methods, graphical method and algebraic method. In the graphical method, if the straight line intersect at a point, then the point gives a unique solution. The pair of equation is consistent. Here we have the two equations, x minus 2y is equals to 0, 3x plus 4y is equals to 20. Similarly, as the previous way, I solved those both the equations by taking the value of the x and calculate the value of y1 and y2. Then the graph is plotted. In the graph, you can see that straight lines are formed, but both lines got intersect at the point 4 and 2. This point is the unique solution which satisfy both the equation x minus 2y is equals to 0 and 3x plus 4y is equals to 20. This is the unique solution for the two equations. Sometimes the straight lines coincide. Then there are infinitely many solutions, each point on the line being a solution. This pair of equation is dependent. For example, in equations 2x plus 3y is equals to 9, 4x plus 6y is equals to 18. I calculate the value of the x and y1 similar way. Then plot a graph. In the graph, you can see that the coincident line is formed. Then there are infinitely many solutions existing for these two equations which satisfy both the equations. If the lines are parallel, then the pair of the equation has no solution. The pair of equation is inconsistent. For example, we have equation 2x x plus 2y is equals to 4 and 2x plus 4y is equals to 12. Then in the graph, you can see that the both lines are parallel. They're not intersecting at any point. They're not coinciding. That means there is no solution existing for these two equations which satisfy both the equations. Now, this method of graphical presentation is not convenient. It may not give accurate value. There are the three algebraic method of solution by using elimination method, substitution method, and cross multiplication method. In substitution method, we follow these steps. We solve one of the equation in term of x and y, substitute this value of x or y in other equation, getting a linear equation in one variable x or y, solve this equation for x or y, substitute the value obtained in either of the equation to get the value of the other variable. For example, in equation x plus y is equals to 3, here by we get the x is value by x is equals to 3 minus y, then put the value of the x in second equation. In these equations we reduce the equation in two variable to equation in one variable. You can see in third equation there is the single variable is present only. Then we solve that equation for single variable, y value is formed out, and putting the value of the y we get the value of the x. Now in elimination method we multiply both equation by non-zero constant. For example, in the equation x plus y is equals to 3, 2x plus 3y is equals to 9. The first equation I multiply equation first by 2, non-zero constant, that is 2 multiplied by with the x variable. To eliminate the x variable, we subtract equation second from the third, then we get the value of the y. By putting the value of the y in any of the equation, we get the value of the x, which is 0. Then the solution is formed out. Solution is 0 and 3. Then another method is cross multiplication method. In the cross multiplication method, we come to know about that equation, that there is a unique solution existing or no solution existing, or there is infinitely many solutions. By substitution and elimination method, we come to know it is unique or it is not. But by cross multiplication method, we come to know that the solution is unique, or there is infinitely many solution exist, or there is a no solution exist. By using the standard form of the linear equations in two variable, we use this, we drive a formula that x by b1 c2 minus b2 c1 is equals to by 1 c1 a2 minus c2 a1 is equals to 1 by a1 b2 minus a2 b1. To remind this formula, we can remember this diagram as shown below. There is the arrow between the number indicate that there are to be multiplied, and second product to be subtract from the first product. Here it is the derivation shown. Here is the three cases arises if a1 b2 minus a2 b1 is not equals to 0. Then a1 by a2 not equals to b1 b2. Then this equation will definitely have a unique solution. If a1 b2 minus a2 b1 is equals to 0, then it means that a1 by a2 is equals to b1 by b2. Then it becomes equals to the constant c1 by c2. Then this pair of equation will have many solutions. If there is a c1 not equals to kc2, that it means a1 by a2 is equals to b1 by b2 not equals to c1 by c2, then this pair of equation will not have any solution. There is the algebraic method solved with the example. Here we take the examples, x minus 2 by is equals to 0 and 3x plus 4 by is equals to 20. As we see in the formula, we write the coefficient of the x and y in same order, solve the equations, and by solving the equations we evaluate the value of the x and y. X is equals to 4 and y is equals to 2, and this is a unique solution. Then conclusion is arise from all these cases. In the first case, if the equations is present have a coefficient in the form of a1 by a2 not equals to b1 by b2, then unique solution will be existing, and consistent this pair of equation will be consistent, and the graphical method, the graph will be intersecting straight lines. In the second case, if the coefficient are in the form of a1 by a2 is equals to b1 by b2 is equals to c1 by c2, then there will be infinitely many solutions will be exist, and coincident straight lines will be formed. In the third case, if a1 by a2 is equals to b1 by b2 not equals to c1 by c2, then there will be no solution existing for that pair of equations, and parallel lines are formed. And there are number of applications are arise from this linear equation, that is related to a boat running downstream covering a stream. In these equation statement, firstly we reduce the equation we conclude the equation from the statement, then we solve the statement according to the equation and get the value. Now thank you. Now Pratima will proceed with the quadratic equation topic. Pratima Di.
Yes, good afternoon. Good afternoon, ma'am. And good afternoon, everyone. Am I audible?
Yes, definitely. Yes.
Yes, Jaspreet, please share my slide.
Visible the ਤੁਹਾਡੀ slides?
Yes.
Okay, fine. Thank you. All the best, Lee.
Thank you, Jaspreet.
Okay.
So, as already explained by Jaspreet, that the equation, what are equations? When an expression is either equated to another expression, or to 0, we get an equation. For example, in the first example, you can see x square plus 9x plus 9 is equal to 5x square plus x plus 9. It means left hand side of the expression has been equated to right hand side of the equation. In the second example, the equation 3x square plus 5x plus 9 has been equated to 0. So we can say that in equations, left hand side may be equal to that of right hand side. Both may have expressions or that may be equated to 0. Now, what are degree of equations? Degree is the equation in which it is determined by the highest power of the variable. For example, 3x plus 6 is equal to 0. It means in this expression, the variable, the highest power is 1. So it is first degree. In the second example, x square plus 5x plus 9, the highest power is 2. Therefore, it is of second degree. While in the third expression, x cube plus 7x square plus 2x minus 5 is equal to 0, it means the highest power is third degree. So degree are the equations involving invariable is given by the highest power of the variable. Now, what are quadratic equations? The standard form of quadratic equation is in which the highest power of the variable is 2. And it is given by the standard form, that is ax square plus bx plus c is equal to 0, where a, b, c are real numbers, and it should be so that a may not be equal to 0, because in case a is equal to 0, the whole term ax square will become 0 and it will no more be a quadratic equation. So we have four forms. In first form, b can be 0, but c is not equal to 0. So the standard form, it is in the form of ax square plus c is equal to 0. Example given in the bracket, that is 4x square plus 5 is equal to 0. In the second form, b is not equal to 0, but c is equal to 0. In that case, the equation will be ax square plus bx, because c is 0, so the whole term is equated to 0. Example, 5x square plus 4x is equal to 0. Now, in the third case, b is equal to 0, c is equal to 0. But remember that a cannot be 0. So ax square is equal to 0. In that case, ax square will be equal to 0. In the fourth term, b is not equal to 0, c is not equal to 0, and the expression appears in the form of standard form, that is ax square plus bx plus c is equal to 0. And example given is 2x square plus 4x plus 9, and it is equated to 0. Now, solving quadratic equations. The values of the variables which makes both sides of the equations equal are called roots of the equation. The process of finding roots of the equation in solving the equation is that are called as roots of the equation. For example, in first example, 5 square x square minus 5x plus 6 is equal to 0, in which it is satisfied by the expression x equal to 2 and x equal to 3. By putting the values of x equal to 2 and x equal to 3, both side, left hand side, will be equal to that of right hand side. And in the second expression, that is 2x square minus 4 is equal to 0. 2x square is equal to 4. It means x comes out to be plus minus under root of 2. It means plus under root of 2 and minus under root of 2 are the roots of the equation. Solution of complete quadratic equation. Complete quadratic equations can be solved by two methods. That is, first is method of factors and second is method for completing the square. Solving quadratic equation by factorization. In the first case, if the product of two numbers, for example, a into b is equal to 0, then at least one of them must be equal to 0. In the first case, if a is equal to 0 or b is equal to 0. Thus, if x minus a is equal to 0, the value of x will be equal to a. On the other hand, if x minus b is equal to 0, the value of x comes out to be b. For example, 64x square plus 625 is equal to 0. We can solve it by method of factorization. That is 8x square. We have divided the term, that is 8x square plus 20 minus 25x square is equal to 0. Now, applying the formula a square minus b square, we are dividing it into two parts. 8x plus 25, 8x minus 25. And it is equal to 0. Now, the value of x comes out to be minus 25 by 8, or it will be plus 25 by 8. In another example, 2x square plus 6s plus 5 is equal to 0. So factorized as follows, in which 6x, that x square plus 6s plus 5, in which 6x has been divided into two parts, that is 5x plus x. So the equation comes out to be x square plus 5x plus x plus 5. So x plus 5 plus 1 into x plus 5 is equated to 0. And the value of x comes out to be minus 5 and minus 1. We can check the equation also that the roots are whether they are correct or not by putting the values. By substituting the value of x equal to minus 1 in the above example, the value comes out to be 0, which is on the right hand side of the equation. Similarly, by putting the value of x is equal to minus 5, similarly, the rate, that is the left hand side becomes equal to that of right hand side. So these values are the roots, that is minus 1 and minus 5 comes out to be correct. Now, solving the quadratic equation by method of completing the square, in which we have to follow the following steps. First, place all the terms containing x on the left hand side of the equation and all the constant terms on the other side. Second step, divide throughout by the coefficient of x square. And in the third step, add to both sides the square of half of the coefficient of x, and this will complete the square on the left hand side of the equation. And in fourth part, write left hand side as a perfect square. Take the square root of both sides using double plus minus sign on the right hand side of the equation. Solving it through example. In the given example, x square plus 2x minus 8 equal to 0. So the solution, we are taking the constant terms on the right hand side while the variables on left hand side. Therefore, the equation comes out to be x square plus 2x equal to 8. Now divide throughout by the coefficient of x square. The coefficient of x square is 1. Therefore, the equation is x square plus 2x is equal to 8. Adding square of half of the coefficient of x, the coefficient of x in the above example is 2. Therefore, 2 will be divided by 2 and its square, that will give you the value 1. So 1 has been added to left hand side as well as right hand side. Final equation becomes x square plus 2x plus 1 equated to 9. So x plus 1 whole square is equal to 1, the value of x. By solving further, x comes out to be 2 and minus 4. So the roots of the equation are 2 and minus 4. Now, the quadratic formula. This quadratic formula was basically derived by Sridharacharya, and therefore this is called as Sridharacharya's quadratic equation formula. And the general standard equation form, that is ax square plus bx plus c equal to 0, was solved by the method of square. That is x square plus bx plus c equal to 0, the whole divided by the coefficient of x square, that was a. Now solving this, the roots of the equation comes out to be x is equal to, the final roots of the equation comes out to be x1 is equal to minus b plus under root of b square minus 4ac divided by 2a. On the other side, x2 comes out to be minus b minus under root of b square minus 4a divided by 2c. Now, the term b square minus 4ac is denoted by capital D, and it is called as discriminant of the quadratic equation. But the value of b square minus 4ac can be appear in four forms. In first form, if b square minus 4ac is 0, then each root of the equation becomes minus b divided by 2a, and hence the roots comes out to be real and equal. And in the second part, if b square minus 4ac is positive and a perfect square, the discriminant is real but irrational, and hence the roots of the equation are rational and unequal. In the third part, if b square minus 4ac is positive but not a perfect square, then under root of b square minus 4ac is real but irrational, and hence the roots are irrational and unequal. In the fourth part, if b square minus 4ac is negative, then under root of b square minus 4ac is imaginary and no real roots exist. Hence, we can say b square minus 4ac should be greater than or equal to have the roots of the equation. And the roots of the equation for these type of equations where b square minus 4ac is greater than 0 are represented by alpha and beta. Alpha is the first root, that is minus b, plus under root of d. D is basically discriminant divided by 2a, while the other is beta, that is equal to minus b minus under root of capital D divided by 2a. Now, many people believe that Babylonians were the first to solve quadratic equation. Another side, that is Greek mathematician Euclid, developed a geometrical approach for finding out lengths, which in our present day terminology are solutions of quadratic equations. Solving of quadratic equations in general form is often credited to ancient mathematicians, Indian mathematicians. In fact, Brahmagupta gave an explicit formula to solve quadratic equation to form ax square plus bx is equal to c. But later on, Sridharacharya at about 1025 AD derived a formula which is well known as Sridharacharya's quadratic equation formula. For example, to solve the equation that is x square minus 5x plus c is equal to 0. The discriminant, that is d, it is equal to under root of b square minus 4ac. It will be, it comes out to be 1. Therefore, the two roots are unequal, real and unequal. In another example, that is x square minus 5x plus 7, it is equated to 0. The discriminant comes out to be minus 3. So, as already explained, for these negative values, we do not have real roots. So, they will have imaginary roots that are alpha is equal to 5 plus iota under root of 3 by 2, and beta will be equal to 5 minus iota under root of 3, where iota represents under root of minus 1, which is imaginary term. Now, this was the topic about quadratic equation. Thank you so much. Thank you, Jaspreet. Thank you, Ramandeep ma'am.
Thank you, Di.
Thank you, Ji. Thank you, beta. Just please stop recording.
Okay, ma'am.